So the substance we will be dealing with now is naphthalene. The problem is the combustion of naphthalene with the formula C10H8, which releases 5,150 kilojoules per mole of energy, is used to calibrate calorimeters. A 1.05 gram sample of naphthalene is burned in a calorimeter, producing a temperature rise of 3.86 degrees Celsius. Burning a 1.83, so for this part here, kani siya nga part diri, when the naphthalene was burned, is for calibration. So sa calibration, masolve na to ang heat capacity sa calorimeter. Now, kung naay 1.83, so burning a 1.83 gram sample of coal in the same calorimeter causes a temperature change of 4.90 degrees Celsius. What is the energy density of the coal? So naay two parts. So first, the calibration, and the second part is the burning of the 1.83 gram sample of coal, wherein we don't know kung unsa na siya nga, we don't know what sample this is. It's just coal. So, sa calibration nga process, sa calibration nga part, so naphthalene ang gi-burn, Q combustion of naphthalene, Q combustion of naphthalene is 5,150 kilojoules per mole. And then, if na kunoy 1.05 grams of C10H8, which is naphthalene, it causes a rise in temperature, which is 3.86 degrees Celsius sa calorimeter. Sa next nga part, sa actual nga problem, na ay coal. Now, the mass of the coal given is 1.83 grams. Upon burning this coal in the same calorimeter, the temperature rise is observed to be 4.9 degrees Celsius. And we are looking for the energy density. So, energy density is, diba, negative Q fuel divided by the mass. So, kinahanglan, masolve ning heat of the reaction of burning this amount of coal. But first, kinahanglan ta mangita sa heat capacity sa calorimeter. So, balik ta diri sa calibration nga part. Okay? So, Q cal is equal to, diba, C delta T. Or, let's just write it this way. Ba, Q reaction equals negative Q calorimeter. And this is negative C delta T. So, for us to be able to solve for C, we need to solve for heat of the reaction. Para mo cause aning delta T, no? Nga 3.86. So, may nakakause aning 3.86, pila may mass? 1.05. So, we will solve for Q reaction first. So, Q reaction is equal to, to solve for Q reaction, we need to solve molar mass first. So, na 10 ka carbon plus 8 ka hydrogen. So, that is 10 times 12 plus 8 times 1, and that is equal to 128 grams per mole. After which, we can now solve for the heat of the reaction. Pilay heat nga ma-release kung ma-burn og 1.05 grams. So, 1.05 grams of naphthalene, 1.05 grams of naphthalene, and then we know that for every 1 mole of naphthalene, that's equal to 128 grams, and then also 5,150 kilojoules of heat is released for every 1 mole of naphthalene. And this would give us an answer of negative 42.25 kilojoules. So, because we already have this, we can now solve for, pwede na mo balik din sa Q reaction. Pwede na nato i-substitute. So, negative 42.25 kilojoules equals C times the change in temperature nga 3.86 degrees Celsius. Na negative sign diri. So, we can cancel the negative sign here. So, C, therefore, heat capacity of the calorimeter, therefore, is 42.25 kilojoules divided by 3.86 degrees Celsius. So, the heat capacity is 10.94 kilojoules per degree Celsius. Now, this is not what we are looking for in the problem because we are looking for the energy density. So, this time, we will now solve for Q. Solve for Q of the coal. Okay, kani siya nga reaction nga gi-refer diri, ang Q man ni sa naphthalene. So, para dili maglibog, ato nang i-subscript as coal. And this Q of coal is equal to negative Q of calorimeter. And we already have C man, delta T. So, this is negative 10.94 kilojoules per degree Celsius, and then inig-burn ko no aning 1.83 grams nga coal na corresponding nga 4.9 degrees Celsius nga change in temperature. And so, we are able to solve nga ang heat released kung i-burn ato nga coal is pila man na siya. Let's solve. Okay. That is equal to 53.63 kilojoules. And now solving for the energy density. So, energy density equals negative of negative 53.63 kilojoules divided by the mass of the coal, which is 1.83 grams, and we will be able to get a final answer of, that's 29.31 kilojoules per gram of the coal. That's the energy density. So that's it for calorimetry, and remember,